Hello students, welcome to video lecture series in Engineering Mathematics 1. Our today's topic is Jacobian of implicit function. Last time we have seen that the definition of Jacobian and some examples on Jacobian. Now in today's session we are going to learn how to solve Jacobian for implicit functions. Now what is the implicit function? Let u and v be implicit function of two variable x and y connected by f1 f2, that is f1 is a function of uv xy equal to 0, f2 is a function of uv xy equal to 0. Then Jacobian of uv with respect to xy is equal to Jacobian of uv with respect to xy is equal to, first write denominator, it is the Jacobian of f1 f2, it is the Jacobian of f1 f2 with respect to uv, and numerator is what? Jacobian of f1 f2 with respect to xy, with respect to xy. Similarly for three variables, if u, v, w are implicit function of three variables x, y and z connected by f1, f2 and f3, then that is f1 is a function of u, v, w, x, y, z equal to 0, f2 is also function of implicit function of u, v, w, x, y, z equal to 0, and f3 is u, v, w, x, y, z equal to 0. Then Jacobian of u, v, w with respect to x, y, z is what? How will you write this? Jacobian it is a first you write the denominator Jacobian of f1 f2 f3 with respect to u, v, w, and the numerator is what? f1 f2 f3 with respect to x, y and z. Now here is minus 1 cube. If uv be an implicit function of xy, two variable x and y, then here is minus 1 square. For two variables, two functions, two variable, minus 1 square, three function, three variable, minus 1 cube. Now let us see some examples on this implicit function method. First example, if x square plus y square plus u square plus v square equal to 0 and uv plus xy equal to 0, then find Jacobian of uv with respect to xy. Now here u and v are not expressed in terms of x and y. Some relation is given in the form of xy and uv. So let's suppose f1 is a function u square plus v square plus x square plus y square equal to 0, and second function suppose xy plus uv is equal to 0. Now by definition of implicit function, by Jacobian of implicit function, we know that Jacobian of uv with respect to xy कैसे डिफाइन करते हैं इसे? It is a minus 1 square. First write denominator Jacobian of f1 f2 with respect to uv, and numerator is f1 f2 Jacobian of with respect to xy, and this is equal to minus 1 square numerator and denominator. Suppose this is 1. Now separately find numerator and denominator by using definition of Jacobian. So numerator is what? It is Jacobian of f1 f2 with respect to xy. What is Jacobian of f1 f2 with respect to xy? It is the first row is what? Derivative of f1 with respect to x. Derivative of f1 with respect to x. Then f1 with respect to y, and second row is f2 with respect to x, f2 with respect to y, and this is equal to f1 with respect to x. What is f1? This is f1, u square plus v square plus x square plus y square. So differentiation of f1 with respect to x is 2x. f1 with respect to y, derivative of f1 with respect to y is 2y. Second row, derivative of f2 with respect to x is y, and derivative of f2 with respect to y is x. Solve this determinant. It is a 2x square minus 2y square minus 2y square, and that is equal to 2 times x square minus y square. And this is the numerator. Similarly, find denominator. What is denominator? f1 f2 with respect to uv, Jacobian of f1 f2 with respect to uv, and this is equal to what? First row is derivative of f1 with respect to u, f1 with respect to v, f2 with respect to u, f2 with respect to v, and the value of this is, what is the differentiation of f1 with respect to u? f1 is u square plus v square plus x square plus y square. So f1 with respect to u is 2u, f1 with respect to v is 2v, f2 with respect to u is v, and f2 with respect to v is u. Solving this, we get 2 times u square minus 2 times v square, and that is u square 2 times u square minus v square. Substitute these two values in 1, we get the value of Jacobian of uv with respect to xy. So another example on same line. If u cube plus v cube equal to x plus y, and second is u square plus v square equal to x cube plus y cube, then find Jacobian of uv with respect to xy. So here uv is not expressed explicitly in terms of x and y. Some relation is given. So let suppose f1 is equal to u cube plus v cube minus x minus y equal to 0, and second function is f2 equal to u square plus v square minus x cube minus y cube equal to 0. Then by definition of Jacobian, then Jacobian of implicit function, then by Jacobian of implicit function, Jacobian of uv with respect to x y is equal to what? Minus 1 square. First write denominator, Jacobian of f1 f2 with respect to uv, our numerator is equal to what? Jacobian of f1 f2 with respect to xy. So separately find numerator and denominator. Now numerator, what is numerator? f1 f2 with respect to xy. Is it determinant? What is first row? Derivative of f1 with respect to x. First row is what? Derivative of f1 with respect to x. then f1 with respect to y, second row is f2 with respect to x, f2 with respect to y. What is differentiation of f1 with respect to x? Derivative of f1 with respect to x is minus 1. Derivative of f1 with respect to y is minus 1. f2 with respect to x is minus 3x square, and f2 with respect to y is minus 3y square. Solve this determinant. It is a 3y square. Minus minus become plus. And this, then again minus sign. It is a 3y square minus 3x square. So this sign is minus 3x square. So finally, you can write 3y square minus x square. And this is the numerator. Denominator is, what is denominator? Jacobian of f1, f2 with respect to uv. So first row is derivative of f1 with respect to u. Derivative of f1 with respect to u is 3u square. f1 with respect to v is 3v square. f2 with respect to u is 2u, and f2 with respect to v is 2v. Following this is a 6 u square v minus 6 uv square. 6u. Now here we can take 6 common, also we can take uv common. So it is u minus v. Now substitute these two values in 1, we get the value of Jacobian of uv with respect to xy. Put these values in 1. Put all values in 1. For the answer. Thank you very much.